Hi guys. In this video, I'll be showing you guys um some basic things you need to know on shunts and multipliers, and I'll be giving you different formulas that you need to know for both shunts and multipliers. Now, basically, when we talk about shunt, a shunt is a low value resistance connected in parallel with a current meter. A shunt is a very low value resistance connected in parallel with a current meter. While the multiplier is just the opposite of shunt. That is, it has a very high resistance connected in series. So, shunt is connected in parallel, while a multiplier is connected in what? In series. Now, basically, in our various houses, we have electrical devices, or let me say electrical appliances. So most of these electrical appliances have a very low voltage, or let me say a very low current, while some have a very high power. You understand? Now, directly from PHCN, popularly known as NEPA, we have some currents that when they are being transferred to um to our various houses, is either we have a low current or a high current You understand? So the essence of shunt and multiplier is either to reduce the current or reduce the multiplier. Now, in most cases, this work as a transformer, though this is the work of a transformer step up or step down a current or a voltage, because shunt the shunt reactor is also the same thing as the power transformer. So in most cases, this behaves slightly as a transformer. You understand? So what are the basic things you need to know when it comes to shunt? Now, converting a galvanometer converting a galvanometer to ammeter, we have we'll be making use of shunt. So you can write that as gas. Converting a galvanometer to ammeter, you make use of what? Shunt. And you should always know that shunts are always arranged connected in parallel. So let me just put it as gas P, so you can just remember galvanometer converted to ammeter. We make use of shunt, and it is always connected in parallel. While multiplier, but for the case of multipliers have converting a galvanometer to voltmeter. We make use of what? We make use of a multiplier, and multiplier is always connected in what? Series. So I'm just using this so you can remember this whenever you get to the exam. Or so, and that is that for that. And there's one important thing you need to know when it comes to shunt. The voltage of the shunt must always be equal to the voltage of the galvanometer, or let me say the voltage of the galvanometer must always be equal to the voltage of the shunt, since it is connected in series. Since it is connected in parallel, the voltage are always equal, and the sum of the current, that is the total current, must always equals the current of the galvanometer plus current of the shunt plus current of the shunt. So it must be equal. That is, for the shunt, in the case of the shunt, the voltage are always equal, and the total current is the addition of the current of the galvanometer plus current of the shunt. Now recall from Ohm's law that V is equal to IR. So reducing that equation above, we have this to be current of the galvanometer multiplied by the resistance of the galvanometer equals the current of the shunt multiplied by the resistance of the shunt multiplied by the resistance multiplied by the resistance of the shunt. You understand? Now making the resistance of the current of the shunt from equation 2 the subject of the formula, because we are asked to look for the resistance of the shunt, so we must also make use of the current of the shunt. So we have our current to be equal to the total current minus the current of the galvanometer. So inserting this in the above equation, we have our equation to be the current of galvanometer multiplied by the current multiplied by the resistance of the galvanometer, which equals I minus I of G. So we have our resistance of the shunt to be there. So in case we are asked to make the resistance of shunt the subject of the formula, so the resistance of our shunt will therefore be equal So we have that to be the resistance of the shunt. Now this is what you need to know when it comes to shunt. The voltage of the shunt is always equals to the voltage of the galvanometer. That is when it comes to shunt. Now when it comes to multiplier, one thing you need to know is that the current of the multiplier, always equal to the current of the galvanometer. Unlike always equals to the current of the galvanometer, unlike shunt whereby the voltage are always equal. So for multiplier now, we have the current of the multiplier to be equal to the current of the galvanometer. And one more thing, the voltage, the total voltage is always the addition. So shunt is just the opposite of multiplier. So it will be the voltage of the galvanometer plus the voltage of the multiplier. So if that should be the case, knowing V is equal to IR and the currents are always equal, so we have this to be the resistance of the galvanometer plus the resistance of what of the multiplier. So we have our brackets closed. So this is, we have V to be here. So making V the subject of the formula, we have V over I minus resistance of the galvanometer, which equals what the resistance of the multiplier. So this is the resistance of multiplier and this is the resistance of shunt. So please take note of that. So that is all for these